All right, here we go. I told you guys yesterday I don't have time to do specific examples and do a whole bunch of review for the quiz. I can definitely do that after school today if you want to stop by and ask those questions. I do want to give you a quick summary, though, what you can expect so you're not going in there blindly. The homework for today is not due until Thursday. I wanted to give you guys tonight to, if you wanted to, focus on studying for the quiz. All right, so there's no homework due tomorrow. It's due on Thursday. There is a bunch of theorems and facts on page 17 to 18 of your packet. That's where you can go for a good old-fashioned review of all the vocabulary. All right, pages 17 and 18 of your packet, it's all there for you. There's going to be 13 questions, 35 points total. I already told you guys 2 of them are going to be partition questions, just like your homework and the notes. I am not going to get sneaky there with the partitions. Here are 2 points. Break them up into this ratio. Find me the point. Could you have a decimal? Absolutely. All right, so 2 partition questions. Also, there's going to be six questions where I draw a diagram, and I'm going to say, is this segment a median, altitude, angle bisector, or a perpendicular bisector? If you want something similar to it, look at the bottom of page 8 of your packet. We did I think we did 4 examples of that. All right, but there'll be 6 of them on tomorrow's quiz. So take a look at the bottom of page 8 if you want to know what I'm talking about. Name that point of concurrency. Guys, I'm just going to come straight out tomorrow on the quiz and ask a question like, hey, I have 3 perpendicular bisectors. They all meet at the blank. And do you know it or you don't? You know it or you don't? Okay? So I am going to test you on the vocabulary tomorrow. Hey, all the angle bisectors intersect at the blank. Do we know it or not? All right. So that's what I mean by name the point of concurrency. I redid the quiz from the last couple years that we gave, just so I know some of you guys have been really working your tail off, working remotely, being from home, and I appreciate that. So I want to reward you with that. So some of these questions are going to be, your success is going to be based on if you took notes, pretty detailed notes, or have been doing the homework up to an honors level. All right. Some of these questions tomorrow, you may have seen very similar questions in your notes or on your homework, specifically relating to the in-center and circumcenter. Okay. So you definitely want to look at your notes tonight on in-center and circumcenter and your homework that we did on it, to make sure you guys are good to go. And if you didn't do a great job on the homework, I'm sorry. It's not going to help you study, I guess. All right, but I at least wanted to reward those people that are putting in the honors level effort. And then finally, know your chart. There's a blank chart on page 11 and a filled in one on page 18. All right, as far as you got the 4 special types of lines, points of concurrency, and then what you should know about the point of concurrency.
If I remember correctly, the circumcenter is the one that's equidistant from the vertices, right?
You are correct.
Right.
Yep, it is equidistant from the 3 vertices of the triangle. Any other last some concerns here? More, if you're coming to the review today, bring some more detailed questions. I have some more actual examples I can show you if you come to the review today. All right, but if you're not, this is probably the last opportunity to ask any questions from me.
What time is the review?
Right after school, till whenever the last question is asked. And you guys can, again, if you haven't been familiar with coming in after school for help, on our Google Classroom page, there is under start of school year info, there is after school help link. That's the Google Meet we all get on. Okay. Same setup as usual tomorrow, please. Camera off to the side, a side camera logged onto our Google Meet, and then your Chromebook is used exclusively to take the test on formative. And I'm just going to warn you guys, I've been pretty flexible in the past when we had to take a test or a quiz remotely tomorrow I need to see everything in front of you. All right. The reason being, this is a huge vocabulary quiz. All right. And I got to make sure you have nothing around you that's got any vocabulary on it. All right. I can't have any cheat sheets around for fairness, please. And it's obviously cheating. So, all right. I'm going to be pretty rigid as far as making sure I can see what where you're working around. So please keep that in mind when you set up your camera tomorrow. All right. We're all good. All right, we're moving on to day 5. Day 5 is not contained in tomorrow's quiz. Tomorrow's quiz is only days 1 through 4. All right, so day 5 will not be on there. And again, the homework for day 5, due Thursday. All right, I'm not going to look for anything tomorrow on Classroom. All right, due Thursday. All right, let's jump right into this. Shockingly, we are still talking about a triangle. Some more facts about a triangle that you did not even know existed. Back in Unit 4, last unit, we had a theorem about the exterior angle of a triangle and the remote interior angles. Can you please remind me of that theorem from last unit? What do you remember about the exterior as far as it relates to the two remote interiors? Let's start this party off right. 13, here we go. How about I get on period 4? There we go. Sophia, do you remember the fact?
The exterior angle of the triangle is equal to the sum of the two remote.
There you go. Unit 2, we said, hey, angle 1, the exterior, was found by adding angle 2 and angle 3 together. Correct. Now I'm going to take it to the next level and say, hey, if the exterior angle is equal to the two remotes added up, the exterior angle by itself should be bigger in measurement than angle 2, one remote interior angle, and it should be also greater than the other remote interior angle, angle 3. All right, makes sense because, hey, if the exterior is equal to the two remotes added up, the exterior should be bigger than each one of them individually. And that's what this new theorem says. The exterior angle of a triangle is greater than either remote interior. That's the first theorem we're going to work on today. All right, so again, any exterior is greater than any remote interior. You cannot tell me anything about its adjacent angle. All right, you cannot tell me anything about its adjacent angle. All right. Okay, we all good there? All good? All right, let's actually try to use it now in this first example. So we see my diagram here. Woo! I got a lot of angles flying out there, don't I? 8 different angles. Our job together as a class, can we find how many angles are less than angle 7? Okay, can we find how many angles are less than angle 7? And there's a bunch, by the way. Not just one, there's a bunch that are less than angle 7. All right, so let's take a look. Everyone look at angle 7 on my diagram. Here we go. There's good old angle 7. Oh, I noticed something. I noticed angle 7 is an exterior angle, isn't it? Somebody name one triangle right now, and I'll call on you. Name a triangle where 7 is an exterior angle for. One triangle, name it with its vertices where angle 7 is an exterior angle. Let's roll. Going to the top. Omni, name a triangle.
Triangle JLK.
JL, yes it is. She went to the big dog right away. So everyone see this one right here? Angle 7 is an exterior to JKL. All right, so now looking at angle 7, what would you consider the two remote interior angles for angle 7? Because angle 7 is going to be bigger than those two. So take a look at triangle JKL. Angle 7 is an exterior angle for what two remote interiors? Just name one of them right now. Name one remote interior angle to 7. Here we go. Maeve?
Could you repeat the question?
Sure. You see how angle 7 is an exterior angle to JKL, right?
Yes.
Name a remote interior to angle 7 then.
3.
3, done. So Maeve just found one angle that is less than 7, angle 3. Got to be less than 7 because it's a remote interior. All right, there's one more angle in that triangle that's a remote interior. You guys may need to give me some letters for this one. 2s. Hannah, you see the other remote interior.
Yeah.
Go ahead, name it.
Angle JKM.
Great job. JKL is the other remote interior. Everyone's all good? Okay, so you found those two. Is angle 7 an exterior angle for another triangle other than JKL? Can somebody find another exterior angle, another triangle where 7's an exterior angle for? Come on. Let's go, honors kids. 2s. Here we go. Quincy. Where's 7 another exterior angle for what triangle?
Repeat the question, please.
Okay, angle 7. It's an exterior angle for what other triangle other than JKL?
LMK.
LMK. Let me highlight that one, everybody. Here's LMK. Everybody's good. All right, 7 is exterior for, name a remote interior now for that triangle. Shoom, going deep. Emma, give me a remote interior for 7 now.
Angle 5.
Angle 5. Good. So 7's bigger than 5. And 7's got to be bigger than 2's again. Here we go, Hannah. Another angle 7's got to be bigger than in that triangle.
Angle 4.
Good job. Angle 4. All right. Everybody good on why those 4 angles are less than angle 7. Oh, we're not done. I got one more out there. I got one more angle that's less than 7. I don't know if anybody sees it. I want to make sure you have an opportunity to guess if you want. Before I...
6.
Remember what we said. Don't go by looks. 7 and 6 are linear pairs. I can't tell which one's bigger.
But what did it say if it's a right angle?
Where'd the right angle come from?
Oh wait, no, never mind.
Okay, there's no right angle here. Anybody else want to try to chime in?
2.
Oh! 2! Yeah, angle 2. Why? Hey, guys, go back. I forgot who, I think it was Hannah who told me. Angle 7 was bigger than JKL, right? Angle 7 is bigger than JKL. Well, how's JKL made up? What 2 angles? Angle 4, which we already knew, and angle 2. So if 7's bigger than JKL, it's certainly bigger than angle 2 because 2's a part of JKL. All right, good job. Good job. All right, next. Can you guys find a couple angles that are bigger than 6? Bigger than 6. I got 2 angles, by the way. You should find 2 angles that are bigger than 6. All right, first question to somebody. Let's go. 5. Here we go. Hayden, name a triangle angle 6 is contained in. No Hayden today. Okay. Lucas, name a triangle angle 6 is contained in.
Triangle KLM.
Yep. All right. So here you go. KLM. There's angle 6. It's an interior angle. Can anybody find an exterior angle where 6 would be a remote interior? Can anybody tell now in triangle KML what angle would be bigger than 6? What angle would be bigger than 6 up here? Any ideas? Here we go. 2-5. Sabrina, any ideas?
Angle 8.
You got it. Nice job. Everyone take a look. Angle 8. All right. Angle 8. Well, actually, you are right, Sabrina. I just got the wrong angle for the wrong triangle. Here you go. Sabrina's right. So let me just go to that one right now. Why angle 8 is bigger. She used the big triangle instead. Okay? See how angle 6 is in triangle JLK, everyone? And 8 is an exterior angle for the big one. So she is correct. All right, we were just talking two different triangles. But does everyone see why 8 would be bigger than 6? All right, let me go back to the other triangle now that we were on. This one right here. Anybody see an exterior angle in that one that would be bigger than 6? Where's the exterior angle for that one? Anybody see it? Do we see it? Ones. Anthony, do you see the angle?
Is it 7?
Well, so remember, I can't compare a 1 that's right next to it. So I can't compare 6 and 7, which one's bigger. So if you take a look, are there any other exterior angles for a triangle MKL you can see here?
1.
Here you go, 1. Everyone see angle 1? Angle 1 is exterior, and 6 would be its remote interior along with 4. All right, so at least I know 8 and 1 are greater than 6. Questions there? So make sure you're just dealing with one triangle at a time before you answer which one's bigger than the given angle or smaller. Questions? Okay, let's move. Next. Ooh, this one's a tough one. I'll let you guys mark your diagram for me. So you guys have AB congruent to BC. Are you putting any other markings on your diagram? Ellie, can I put any other markings that I know are congruent on my diagram other than those two sides? What type of triangle is ABC?
Equilateral? No, isosceles.
Okay, isosceles. So we learned last unit, not only are those sides equal, but what else you got for me?
Angle 1
Yep.
and angle BCA.
Good job. So I got angle 1 congruent to angle BCA in a triangle. Congruent angles are across from congruent sides. Good job, Ellie. All right. So now they want to know which one of the following is true here. 1 bigger than 2, 1 bigger than 4, 3 bigger than 4, and 4 bigger than 2. And we are not going by the looks of it. We're going to prove this mathematically. I do not want to go by the looks of the diagram. Whew. Wow. 1 bigger than 2. Well, they're in the same triangle. 1 bigger than 4. I don't want to just show you how to do it. If anybody's got any suggestions on where we could start. And remember, we're talking about exterior angles here. And you got 2 separate triangles in that diagram. Can I use an exterior angle anywhere here? Anybody see any exterior angles maybe I can start with?
BCA is an exterior angle.
Darn right it is.
Triangle.
Darn right it is, everyone. Angle BCA. I think it's nice when I highlight it too so you can see it. Everyone see how BCA is a exterior angle? So it should be bigger than, name the 2 angles BCA should be bigger than in that triangle. Boom. Lucas, here we go. BCA should be bigger than what 2 angles in triangle BCD?
Angle B and angle D.
We got numbers there.
Oh, angle 3 and angle 4.
Okay, so BCA should be bigger than angle 3, and it should be bigger than angle 4. Everyone agree with that statement because it's an exterior angle. All right, let's keep going now. BCA is equal to what angle from the beginning? Ellie gave it to us. Here we go, Omni. BCA and what other angle are congruent?
Angle 1.
Angle 1. So I'm going to take a look. Little thing we like to call substitution, right? Angle 1, because it's equal to BCA, also has to be bigger than angle 4. And it's also bigger than 3, but that's not a choice here, is it? 1's bigger than 4. See how we got to that? The hardest part was finding that BCA, this angle right here, was exterior to 3 and 4. Whew. Everyone all right there? Because that's theorem number 1 for the day. In the last 14 minutes here, I got theorem number 2 coming up. Anything on the exterior angle being bigger than either of the remote interiors. And remember, you cannot tell me if it's bigger or smaller than the one adjacent to it. It's only bigger than the 2 remote interior angles. All right. Second theorem for today, you guys are going to find yourself. I have 2 triangles up here. I have all 3 sides of both labeled for you. I have 2 out of the 3 degree measures plugged in for you. Your job, honors kids, in the next 2.5 minutes. Can you see any relationships or patterns between the sides and angles of each triangle? Can you find something that is true between the sides and the angles of both triangles? And here's a little hint to get you going. Yes, you would probably benefit yourself if you found the 3rd angle in both triangles. Okay? So try to find the 3rd angle in both triangles and then see if you can find anything that's true. Because it's there. It's there, kids. You just got to dig deep.
Are the numbers along the sides, the numbers along the sides are the measurements, right?
The lengths of the sides, correct, yes. So 4, 5, 7, those are the lengths of the sides. Yep. So what do you guys got here? A little 42 action here, and probably a little 35 action here. Anything from you guys? Think you maybe found something? Even if it's not what I'm looking for, I'd still love to hear it. About the
If all the angles are congruent, and then the sides will be congruent, yeah. That's about all I got.
Well, that is a true fact that if you have 2 angles equal, that the sides across are equal, right? That is a true fact for triangles. Anything else here, guys?
I think we learned about these in 7th grade.
No, you didn't.
Well,
Stop
that
it.
To be greater than the other one.
Say that again.
We learned about it in 7th grade. It's I don't know if it's a theorem, but it's a basic rule where 2 of the sides will add up to be greater than the 3rd side.
That is true. That is true. You got me there. That's Thursday's class, actually, Audrey. That's Thursday. So save that for Thursday for me, all right? That's Thursday. But you are correct. Add up 2 sides. It always has to be bigger than the 3rd side. Yep. You just killed my steam for Thursday's class. Thanks. So I'm assuming if you learned that in 7th grade, you probably learned this fact in 7th grade too, then. The one I'm asking for now. All right.
The smallest angle was formed by the 2 longest sides.
Correct. Here you go. Everyone, look at the first triangle. Look at the smallest angle, which is 42 degrees. Where's it across from? 4, which is the smallest side. All right, and it works too in the next triangle. 35 is the smallest angle. Where's it across from? Ding! Smallest side, 16 in the triangle. So that's your first theorem right there, is in a triangle, smallest angle is across from smallest side. Always. That will always be true. There's no exceptions to that. Smallest angle is across from the smallest side. And number 2, it's just the same exact theorem except biggest angle across from biggest side. All right, in a triangle, biggest angle is across from the biggest side. Every single time. Can't go wrong. All right. So what do you say we put this to use? I'm going to have somebody list the sides from shortest to longest. Cannot list the sides unless you know all 3 angles. So if you got a calculator around you right now, go ahead. Let's find angle B, the missing angle here. So 180 minus 41 minus 47 should give you a 92-degree angle here. All right, need somebody's help. Help me list the sides from shortest to longest. Shortest to longest. 23. All right, Luke, you're up, boss. What would be the shortest side in this diagram?
BC.
BC, if anybody's wondering why, it's across from 41, which is the smallest angle. Next side, Luke, as we keep going larger now.
BA.
BA, because it's across from 47. And what's the largest side?
AC.
AC, because it's across from 92, which is the largest angle. All right, all good there, guys. All right, let's keep trucking. Number 2.
Wait.
What?
Never mind, I had it reversed, sorry.
Shortest to longest. All right, number 2. Again, still need to find all 3 angles before you tell me the side lengths in order. So you guys already know 107 and the angle next to it are linear pairs. They're supplementary. So that should be 73 degrees. And then angle T, 180 minus those 2, which would be, I have 32 degrees. All right, let's roll. Shortest to longest again. Shortest to longest. 2-1. Here you go. Zach, you're up, boss. Shortest side.
SR,
Yep. Next.
ST,
ST. Yep. And then largest side.
RT.
RT. You kids all right with that before we go on to the last one here? Because we're not going to have time to do the last example, but we can do the next one. All good? All right, here we go. I got triangle ABC. I give you info on all 3 angles, it looks like. Which statement is true? Well, I'm not going to be able to answer which statement's true unless I know the actual angle measurements. So first question, can somebody set up an equation using those 3 angles for me? Because I need to know what angle A, B, and C measure up to before I tell you if it's isosceles, obtuse, and where the longest side is. Here we go. Ryan, got an equation to set up for me so I can actually find those angles? Yep.
3x. 3x plus 4x plus minus 19
Yeah.
plus 3x minus 1 equals 180.
Yep. All the interior angles add up to $1.80 from last unit. Whew. Here we go. Let's solve for x. So what am I looking at? 10x minus 20 equals 180. All right. Add the 20 over. 200, huh? 200. Divide both sides by 10. Looks like x will be 20. All right, you and I both right now, let's take 20, plug it back in, and see what type of angles I get for ABC. All right, here we go. Plug 20 in for angle A. 3 times 20, 60 degrees at angle A. Angle B, 20 times 4 minus 19, 61 for angle B. And finally, angle C, 20 times 3 minus 1, 59. All right, let's see which one's true now. As I go through, choice 1, it's isosceles. No shot. If it was isosceles, 2 of those angles would be equal, right? It's not isosceles. Choice 2, is AC the longest side? I think we have a winner. Why? Why would AC be the longest side? Someone explain. Why is AC the longest side? Finish it up on a good note, Emma.
Because 61 is the biggest angle movement.
Yep, and AC is across from it, making AC the longest side. Good job. All righty. Looks like we'll finish 2 on Thursday's class. I don't want to start it and the bell cut us off. So this homework due on Thursday. All you're going to do is show up to class and take the quiz tomorrow on formative. Make sure you got a nice side angle that shows everything in front of you, so I know you don't have any cheat material you're using for the quiz. All right? If you want to come after school, I'll be going over some specific questions anybody has. All right, kids? All right. Another solid job. Let's get after it tomorrow, right? We don't have any excuses. Well, we're working from home. I don't do well. Okay, let's get over it. Let's get over it. You're going to do well tomorrow on the quiz, right? Show me. Show me. Don't tell me. Show me. Have a good day, guys. Yes.
I won't be in class tomorrow.
Okay, so can we schedule a time right now, Hannah, so I can put it in the formative that you can take the...
Yeah.
You let me know.
Okay. Well, I have like Thursday after school.
That's fine. You want to do that?
Yeah, well, Thursday?
Thursday right after school?
Yeah.
All right, you got it.
Okay, thank you.
Hi, Kyla.
Hi, I have a really quick question. So, we're trying to schedule a surgery, and I don't want to